Hello and welcome to a new edition of Cracking the Cryptic, where we're going to continue our quest to cover puzzles that we should have covered when they were originally released. So we get sent puzzles all the time, and yesterday you'll have seen I tried a puzzle by Joseph Namer, which somehow we didn't do when it was first submitted to us, but we put that right yesterday. And we've been basically auditing all of these old puzzles and saying, well, should they have appeared on the channel? What were the testing reports like? Or where did they end up on Logic Masters Germany in terms of rating? And there's basically a whole stack of puzzles that we should have done, and we now are going to address that. And today's puzzle is by Quarter Through. Now, unfortunately, it's called Disjoint Killer. Not that I've got anything against the name particularly, but I have got things against disjoint set puzzles because I'm terrible at them. But this has only 3 stars out of 5 for difficulty, a whopping great 90-something% approval rating. So it ought to be excellent, and wish me luck. I'll read you the rules. So we've got normal Sudoku rules apply. In cages, digits must sum to the small clue in the top left corner of the cage, and digits cannot repeat within a cage. So normal killer Sudoku, so that 12 cage, for example, the 3 cells in it have to add to 12, and what you could not do is that. That will not work, because although those 3 digits do add to 12, I've repeated a 3 to make that work, and we're not allowed to. Now, here's the part of the rules where things get awkward. Cells that appear in the same relative position in their 3x3 box must not contain the same digit. E.g., the digit in row 1, column 3 cannot appear in row 7, column 6, as this would cause a repeat in the northeast corner cell of the 3x3 boxes. Yes, so what we've got to realise in this puzzle is that not only do we have to put the numbers 1 to 9 in each row, in each column, and in each 3x3 box, but also every single position within a box, so this is the sort of top right-hand cell of the 3x3 box, these top right-hand cells of the 3x3 boxes must all contain different digits. So that is a set of the digits 1 to 9. Look at the middle cells. These are a set of the digits 1 to 9. They all have to be different. Bottom left cells, again, they are another set of the digits 1 to 9. Now, why do I find this difficult? Well, it's because normal scanning, well, it does apply, but it has to be augmented somewhat. So, for example, if we're trying to work out what this square can be, normally I would scan the column. Well, I probably wouldn't. I'd probably scan half the column, as you well know. But I'd scan the column in theory, the row in theory. I'd look at the box. But here I've also got to look at those 4 squares to see whether or not there are any repeated digits or any digits in these squares that can therefore be ruled out of that square in the bottom left. So it's a nightmare. Anyway, do have a go at this nightmare. The way to play is to click the link under the video as usual. Now I get to play. Let's get cracking. And the first thing I'm going to do, as always in Killer Sudoku, is look for weak or constrained cages. So I can see 2 11 cages in 4 cells. They are gimmies in the sense they've got to be 1, 2, 3, 5. That's the only way of making 11 in 4 digits. 15. It's 2 15 cage. 3 15 cages. They don't seem to see each other. These can only be done in 2 different ways. Not prepared to pencil mark it. It's either 7 8 or 6 9. What am I? Yeah, actually, maybe I will pencil mark it because I'm just wondering whether. No, it doesn't. I don't think it does impact the 14 cage. 14 in 2 cells is either 6 8 or 5 9. Rather worryingly, I'm not seeing much else. Oh, now maybe it's the secret look. So, if you've not been watching the channel for a while, you might wonder what the secret is. Well, the secret is something we only tell our very favourite people, and it's to do with maths. So, in any correct column, complete column of a Sudoku, or complete row of a Sudoku, or complete box of the Sudoku, you'll find all of the digits 1 to 9 once each. If you add those digits up, you get 45. Now 45 is the equivalent of Douglas Adams' 42. 45 is basically the Sudoku answer to the life, the universe and everything, and the question of, or the most important question. Because if we know this column adds to 45, we can start to think about things like those 5 squares add up to 30, it's a 15 cage and another 15 cage. That means those 4 cells at the top must add up to 45 minus 30, which is 15. And that is as useful as a chocolate teapot, because I've got no clue what that means. 15 in 4 cells can be done in a myriad of ways. So that maybe the secret is not how we approach this. A 17 S pentomino here, look. 17 in 5 cells has got to have a 1, 2 and a 3 in it. And you can see that, for instance, if you try and leave the 3 out, then the lowest you could make those 5 cells add up to would be 1, 2, 4, 5 and 6, which add up to 18. So these have a 1, 2 and a 3. I don't think there's anything we can do with the disjoint. I don't actually like pencil marking it like that, because this square is not in this box, so it all gets a bit tricky. Actually, I'm just wondering about the disjoint relationships between the 11s. So those 2 squares sort of see those squares, but we don't have enough of a restriction for that to be useful. The disjoint is probably only going to be useful once we actually have some digits, because you know, we need digits to apply the disjoint rules. Now, what on earth am I meant to do? Is it some sort of set theory thing? That would not be in accordance with a 3 out of 5 star difficulty puzzle. If I've got to sort of do some gymnastics with geometry here, that would be very mean indeed. Just check the Fistempfel ring. I don't think it's relevant, but let's just have a quick look. So the Fistempfel ring, of course, is saying that these 16 cells here are identical, or the digits in those cells are identical to the 4 2x2s in the corner. That's just not right, is it? Okay. I can see these top right-hand cells are all not in boxes, or not in cages, I should say, which is a little bit interesting. Yeah, okay. I've just proved myself to be a wally, haven't I? By saying, oh, the disjoints, of course the disjoint rule is not relevant. The disjoint rule I now think might be relevant, because I've just noticed that not only is the top right-hand cell not in a cage, but the middle bottom cell is not in a cage in any of these boxes. Look, it's not. Now this is making me think that we might have to do a lot of sums here. So let's just try and work out which cells then are... That cell is not in a cage and not in one of those sets. That one, that one, that one, I think, that one, that one. Oh, there's quite a few. 1, 2, 3, 4, 5, 6. One there, 7. Right, so why am I thinking about maths? Well, let's think about maths. What do we know the purple squares add up to? Well, we know that they are a complete set of the digits 1 to 9, so those purple squares add to 45. What do the green squares add up to? 45. What does the whole Sudoku add up to? Let's add the whole Sudoku up. If we add every digit in this puzzle up, what will we get? Well, we'll get 45 for a box times 9. There are 9 boxes, which is 405. So what I'm wondering is whether all these blues are all going to be either all 1s or all 9s, because we are going to be able to work out the value of the blues by doing a lot of adding. We have to add up every cage in the puzzle. And to that, we'll have to add 45 plus 45, and then the difference between those 3 things and 405 will equal the blue squares. Now, I'm definitely doing this because, if this is right, by the way, this is a beautiful idea. So we've got 29, 39, 51, What's that? 76, 90, 112, 128, 139, 150, 165, 180, 195, 210, 221, 238, 252. Okay, well this doesn't ring any bells with me. 252. Now to that, to 252, we've got to add 90 for the purples and the greens. To 252 plus 90 is 342. And the whole puzzle adds up to 405. So that's 63. Oh, right. 63 has to be made up with the total of the blues. And 63 divided by 7 is, yes, 9. That is absolutely gorgeous. That is gorgeous. I got lucky there as well. If I hadn't noticed these, I could have been looking at this all week. That is not easy, surely. Well, the comments will reveal whether that's easy, but I do not think that's easy. It's a beautiful idea. I mean, these are so hidden, aren't they? It's just that's brilliant. I love that. So now we can. Well, what can we do? Presumably we can get some joy with the 9s, can we? 9. Yeah, we can immediately. Where does 9 go in the middle box of the Sudoku? It's in one of these two cells, but it's not in this one, because this is in the bottom right-hand corner of its box, and that 9 is in the bottom right-hand corner of its box. So that can't be a 9, and that is a 9. Therefore, that's a 9. We get a 9 in purple. In fact, we've done the 9s now. And look, oh, that means that's not a 6-9. This is a 7-8. That one is not a 6-9, so that's a 7-8. This one is a 7-8, so we're getting lots of 7-8s from the 15 cages, and we get the 14. No, better than that. What do we put in the 14 cage now? Well, we can see it's got to be 6-8, and there's an 8 looking at it. So there's an 8-6 pair that we get. 8's got to be either here or here in box 7. Now let's. We've only got 1 8, so we can't use the disjoint rules. So have we? Oh no, yeah, we can. We've just used the 7. Why don't we just use the pencil mark I've just put in? Oh, good grief! What a complete numpty. Now 8. 8 in box 1 is what I'm thinking about. It's got to be in one of these two cells. It could go in the 14 cage along with 1, 2 and 3. Or it could be in green. We've not put 8 in green, so we can't rule it out of there, unfortunately. Can we do anything else with 8s? I'm not sure. There is a 7-8 pair in column 5. 25 cage, does that need an 8? Oh, hang on, yeah, look, the 25 cage can't have a 9 in it. So 8 plus 7 plus 6 plus 5 is something I know equals 26. So actually, we know what the composition of this cage is. In fact, I know where the 8 goes in this cage, because this cage is 4, 6, 7 and 8. That's the only way you can make 25 in 4 cells without a 9. And look, there's 8s and 8s looking into all of these squares. Oh, whoopsie, I made a mistake there. I got rid of the 8s from there. Whereas this square now becomes an 8. The 7, there's a 7 in this cage as well. So this is 8, 7. This is 8, 7. So this one is not 8. We get an 8 in the greens. And we know and we know where the 7 goes because there's a 7, 8 in column 1 already. So there's a 7 in the 22 cage. Have we done anything clever or useful there? We now know 8's got to be in one of those two cells. I keep thinking I'm missing one of these disjoint set rules. I am missing one. I am missing one. This 8 is in the middle of its box. That 8 is in the middle of, well, that potential 8 is in the middle of its box. So that's a 7. That's an 8. That's a 7. That's an 8. Oh, this is nice. Okay, now we can ask where 8 goes in the middle box. Look, 8 is locked into the same rows of the Sudoku in box 4 and box 6. So where does the 8 go in row 4? It's not there, it's not there, so it must be in one of those 3, and it can't be in these 2 because of more Sudoku. So 8 goes in here. How many 8s have I got? I've got, oh right, okay, I've got 7 8s now in the grid, and those 2 being the last 2 are not going to be disambiguated by disjoint sets because they're in identical positions in their boxes. Now, what can we do? Well, I tell you what, we can do some Sudoku. We can place 7 in green. Now, that's interesting because 7's got placed in the, well, not placed, but it's in the 17 cage. So 7 is in one of those 2 squares. Now, once we put 7 in the 17 cage, there are 4 more digits that have to sum to 10. So we actually now know that this is a 1, 2, 3, 4, 7 cage. Which is interesting. I want to think about this square now, because this square sees the whole of that 17 cage. So this square cannot be 1, 2, 3, 4, 6, 7, 8 or 9. That is a naked single 5 is my belief. And then this square is the same as that square. So that is a 1, 2, 3 or 4. And the 5 here is probably seeing all sorts of... Yes, the 5 is seeing the 11 cage. So 5 is now locked in this domino in box 6. So 5 is in the 12 cage now. So what do we need to put in the 12 cage along with the 5? We need 2 cells that add up to 7. So it's not got another 2. It's not got 2 in it because then it would have to have a repeated 5. Yeah, okay. So it's got one of those 2 digits, hasn't it? Because it's either going to be 6, 1, in which case that square is going to be a 6, or it's going to be 3, 4, and therefore this square is going to be a 4. So these options here are 3, 1, 5, and there's definitely a 5 in there. Now, let us check whether or not something is seeing these squares from a disjoint perspective. Maybe, I don't know. Or is anything... Oh, look, 7. The 7 is seeing that one by a disjoint. So that's a 7, and this is not a 7. Oops, it's not a 7. Oh, so 7 is a pair there. So this is a... Oh, okay, this is interesting. Oh, right, okay, I was getting worried this was a deadly pattern, but it's not. It's going to be disambiguated by these cages coming into this 7-8 pair here. So this square now is a 3 or a 4. Five is in one of those squares, and we have to stare again and try and work out what on earth is going on. Have I done all the 7s now? No, I've not done a 7 in the middle box. Oh, well, yes, by Sudoku it goes there. So that was an easy win. Now, where on earth do we look next? That is the question. And the answer is, I have not got a Scooby-Doo. Yes, I do. Yes, I do. A 15 cage that hasn't got a 9, 8 and a 7 in it. Well, that's got to be 4, 5, 6. That's a gimme. Should have seen that immediately. So that means this square's become a 5 out of nowhere, which means that square's a 5 out of nowhere. That square's a 4 because it sees a 6, and that's a 6. And all of a sudden, the world is looking rosier again. 4, 5, 6. This column needs 1s, 2s and 3s into it. That square is a 1, 2, 3 or 4. I will pencil mark it. I've got I've got a few digits now in the greens, very few digits in the purples. The purple 6 is a little bit restricted, I think. Is that... This 6 is ruling purple. Well, it means that none of those 3 can be a purple 6. This one can't be a purple 6. It sees 6 in the row. So one of those 2 is a 6, which, okay, that's not helpful. Sorry. Right. Where else can we look? Sudoku is helping us. Look, this is a 4-6 pair. Where does it go in box 1? That must be a 4-6 pair. That's huge. That's going to fix this 10 cage, I think. Yes, how does the 10 cage work now? It can only be 2, 3, 5. That's the only way we can get as high as 10, which means this square is a 1, this square is a 5, and that means that square is a 6 out of nowhere. This feels very important because also the 14 cage now has got 10 in it in this domino, so it needs 4 more. This is a 1-3 pair, which means that there's definitely a 2 in this 14 cage. Now it must mean something for those 2 squares. They are a 2-5 pair. Now that seems to be saying there's a 5. Yes, there is. There is a 5 in this domino. Yeah, in fact, there's a 5 in this box. Why don't you use that, Simon? That's slightly more straightforward. So that's 5. That's 2. You can get rid of 2 from those squares. Get rid of 2 from this square. That means we have to get rid of 2 from this square. Those 2 squares are 1 and 4 to complete box 2. This 22 cage has got 15 in it. Therefore, those 2 add up to 7. So this is a 3 or a 6. Now let's check these positions. So that one, that one, that one, that one, that one, that one, and that one, and that one is a complete waste of time. Sorry. Right, that's not helping. This square's a right-in. Let's do that. That's a 3. That's interesting because that, look, has given us a 1-2 pair there, which means that this is a 3-5 pair, which means that is not a 3, which means that is not a 3, which means this is a... Now, this is now known. This is a 1 or a 4 to complete the column, but it can't be a 1. So that's a 4, that's a 1. That's a 1, therefore. This is 2, 3, and 4, which fixes the 4 and the 6 at the top. Now, this might be seeing some stuff round the grid. Have I got... No, I've still not put 6 or 3 in the purples. So these are a 3-6 pair. Yeah, beautiful. This 6 sees that one. So that's a 6, that's a 3, that sees the 4, gives us the 7, gives us the 8, gives us the 8 and 7 on the other side. Now, these won't probably do... Oh, well, it's given me something in this cage. Yeah, this is lovely. This 8 means these 3 squares add up to 8. But they're not 1, 3, 4. So these are 1, 2, 5. I'm just looking to see whether or not that's resolvable. That's... there's a 2-5 pair left in these positions in the disjoint, look. So that was almost very nice, but hasn't quite done all of the work it was meant to do. This square is a 6 to complete this box. Where do we put 6 now in this box? It's got to go there, which means that's a 1 and that's a 4. Now this square should be a 3. This 3 bounces back over here. What a lovely puzzle. Honestly, this is just... It's a lot of fun. Now this 1 sees that square, so that's got to be the 1 in row 6. That means this is a 2, that's a 3. The 3 and the 1 get done, that's a 2. Now, those should be 4 and 5, which I seem to be able to do. Now, how do we disambiguate this middle bit? That's not 5. I don't know. This 1 is maybe... Yes, that's giving us a 2 here. 3 and 1. This square's now a 3 by force. Now, look at the greens. The greens are... Oh, whoa, hang on. Let's look at the greens. They're a complete set, apart from this one, which... Oh, sorry, it's easier, rather than looking at the disjoint set, Simon, to notice there is a 4 in column 5. Yet another example of Wallydom from Simon Anthony. Right, these squares are 4 and 6. That's done. 6 and 4 go in. This square's a right in. That should be a 2, a 5, and a 3. That makes that a 2. Whoa. All goes in. This is all finished. 6 and 4. Click, tick. Yes. What a lovely, lovely puzzle that is. The beginning is to die for. That is just a lovely, lovely trick. A lot of maths involved, but it's just elegant, isn't it? It's very well hidden. It really is very well hidden, because effectively there are 18 plus 7, 25 cells that are uncaged, and you have to spot the relationship between these purples and these greens, otherwise you'll be there all week. Loved it. Absolutely loved it. Let me know in the comments how you got on. Let me know if you spotted it quickly, and I will read those with interest, and we'll be back later with another edition of Cracking the Cryptic.